This is homework set 44. I want to solve this linear inequality here. So I'm going to rewrite it up here. 2x plus 3y less than or equal to negative 1. Now, because I have the variables on one side and the constant on the other, I'm just going to make a table and find the intercepts. So when x is 0, what do you get for y? When x is 0, I'll put a star there. That's the one I'm choosing. So when x is 0, this is gone. And divide by 3, negative 1 over 3, I get negative 1/3. Now, when y is 0, all right, when y is 0, 3 times 0 is 0, that goes out, and I get 2x equals negative 1, so x is negative 1/2. So here's 2 points, 0, negative 1/3, and then negative 1/2, and 0. Let's plot those. So the first one, 0, negative 1/3. We're going to have to kind of guess here. So this is going to be, all right, 0 down to 1/3. All right, we'll just do our best. That's the problem with graphs. You don't always get an exact result. And then the next one, to the left 1/2 and 0. So to the left 1/2 and 0. Now the problem here is that these are so close together, it's very hard to get an accurate graph, but I'm just doing the best I can. But because those are so close together, why don't we do this? Pick something bigger for x. Pick something bigger for x, like maybe 3. All right, so if I pick 3 for x, put in 3 for x, what do you get? You get 2 times 3 plus 3y. Now, this is the division line, divider line, so I'm going to put negative 1. So I'll get 3y, right, 6 plus 3y equals negative 1. So I'll get 3y is equal to negative 7. So y is equal to negative 7/3, which is negative 2 1/3. All right, so what I'm going to do is I'm going to start at the origin then. I'm going to go over to 3 and down 2 1/3. Just gives me a little bit more space so I can see it more clearly. Over 3, down 2 1/3. You know, maybe that's over 3, down 2 1/3. Maybe that's here. And now that kind of looks like I got a little bit better idea of drawing my line through there. Now, what kind of line? It's solid. It is a solid line. The divider line is solid because of that equal sign right there. So where are the solutions? Solutions are on one side or the other. Now I know they're on the line, but top or bottom. So just choose a test point, all right? I'm going to use a test point. I can pick any point that is not on the line. So how about 0, 0? Because 0, 0, the origin, is not on the line. So just put 0 for x, 0 for y, and see if you get a true or false statement. So I'll get 2 times 0 plus 3 times 0 less than or equal to negative 1. Well, this is 0 less than or equal to negative 1. That's false. All right, so here's 0, 0. I'm looking at the picture now. Here's 0, 0. I got a false statement. Now, if it's false for this point, it is false for every point on that side. So where are the solutions? They're all down here, right? So all the solutions are on this side of the line. I'm not going to shade the whole thing in. I'll just do this. Question 2 says, suppose we have 475 feet of fencing that we're going to use to build a rectangular livestock pen. Let x represent the length and y be the width. All right, so how about this? I'll draw a picture. X is the length, y is the width. Now, what do we have? We know that all the area, the amount of fencing we have is 475, and that's got to go all the way around. So right now we know this: 2x plus 2y, right? We have 2 x's, this one, and 2 y's. Add them together. This has to be less than or equal to 475 feet. Because what we want is this: shade the region. Shade the region, all possible values of x and y that will give you a rectangular from 475 feet of fencing. Okay, we don't need to use all the fencing. That's why we have the less than or equal to. Build a little table. Let's see if I can get it to right. I'll build it up here, x and y. All right, so when x is 0, what do we get here? When x is 0, that's gone, and I get 2y equals I'll write it here. I get 2y equals 475. So y is equal to 475 divided by 2. So y is equal to 237.5. All right, so here's a point, 0 and 237.5. You know what? I'm going to plot that right now. So where is it? X is 0. Well, let me get rid of that. X is 0, and y is 237. All right, now see, total guess right here. We're just going to have to do the best we can. 237.5. So I'm just going to guess that it's right around in here. And now, when y is 0, right, it's going to be the same for x, right? So it's going to be 237.5, right? If I put 0 in for y, right, put 0 back here, put 0 in for y, I still get 475 divided by 2. So now it's 237.5, right? That's probably still over here. Oh, how did I get that one? All right. And now what it wants to do is shade the region contains of all possible values for x and y. All right, so I'll shade this right here. So there's the line. And you see it's going to be anything below the line, but above this, right, because y and x have to be positive. So it's going to be this triangular region right here. So if you pick any point in here, right, get that x and that y, you will use less than or equal to 475 feet of fencing. Question 3. Graph the solution set to these linear inequalities. Now you see what x is? X is between -5 and 5. Now what you have to remember is that when you have an equation like this, x equals 1, that is a vertical line, right? Only one variable. If there's only one variable, you get a vertical line if it's x, you get a horizontal line if it's y. So I've got two of them here. I've got x equals 1 and x equals -5. Right, so I've got two vertical lines. Now, they're less than or equal to, so they're solid lines. So I'm going to have -5, that's over here. Let's see if I can get it to draw here. All right, there's that one. And 1, so that's here. And now where is x? Look at this. X is right between them, right? So x is between them. So what I get is this. I get, you know what? I think I can do this here. If I choose this, and then I do something like this, I think I can get this to draw like this. Yeah, all right, real light. All right, so that's the first one. Then I've got the one for the y's. Now the one for the y's, I've got this. Now what about the y's? The y's are between 1 and 5. All right, so I have these boundary lines, y equals 1 and y equals 5. Now there's only one variable, so we're going to get horizontal lines. Here's the horizontal line at 1. Here's the horizontal line at 5. And the y's are in between these. So I'm going to get all the y's in here. Right, they're all going to be in here. Maybe I can make that a little darker so I can see it. Now, where do they intersect? Because I want both of them. So it looks to me like they intersect in this region here. Looks like they intersect in that rectangle. So what I would do is I would shade in that rectangle. It looks like a big mess here. But it's going to be anything in this rectangle. Pick any point. Now, if I pick any point, the x value is between -5 and 1, and the y value is between 1 and 5. And that will end this part of homework set 44.